Hello everyone, myself Arvahita, Assistant Professor of CSE Department from Rohini College of Engineering and Technology. I am here to explain a few concepts of the subject CS 8601 Mobile Computing. We are discussing the Unit 1 here. It is Introduction and the topic explained here is Multiplexing. So first let us know about the objective. The objective of learning this topic is to understand about the concepts of multiplexing. About multiplexing. Multiplexing describes how several users can share a medium with minimum or no interference. Okay, the users can share a particular medium with minimum or no interference. It is concerned with sharing the frequency range among the users. So the bands are split into channels. The four main channels: SDM, TDM, FDM and CDM. SDM stands for space division multiplexing, TDM stands for time division multiplexing, FDM stands for frequency division multiplexing and CDM stands for code division multiplexing. The space division multiplexing SDM, it is allocated according to the location. The particular bands are allotted or the channels are allocated according to the location. In the case of TDM, the bands or channels are allocated according to the units of time. In FDM, the channels are allocated according to the frequencies, and in CDM it is allocated according to access codes. Okay, so all these are the four main assigning channels. And now let's see what is God space. The God space or the spaces or the gaps between these allocations. All these allocations we have seen, and individual allocations have gaps in between them, and these God spaces are called as God space, or gaps are called as God space. Now let's see in brief the SDM, that is space division multiplexing. This is the basis of frequency reuse. Each physical space is assigned channels, and the spaces that don't overlap can have the same channels assigned to them. Example, FM radio stations in different countries. Okay, so here are some drawbacks. Although this procedure clearly represents a waste of space, this is exactly the principle used in the old analog telephone system. Each subscriber is given a separate pair of copper wires to the local exchange. We already know that the old analog telephone system used in our homes. So each telephone system or each system is given a copper of wires which will be connecting to the home to the local exchange. So in that case we use this space division multiplexing. In wireless transmission, the SDM implies a separate sender for each communication channel with a wide enough space between the senders. Okay, so the figure below shows the 6 channel KI and introduces a 3-dimensional coordinate system. The figure here shows a 6 channel KI and introduces a 3-dimensional coordinate system. This system shows the dimensions as code C, time T and frequency F. So these are the coordinates here. So channels Ki is specified, that is K1 to K6. 6 channels are specified here, and it is the coordinates are specified as C for code, T for time and F for frequency, that is given here. And for this, the first type of multiplexing, that is the space division multiplexing, the 3-dimensional space is given as code, time and frequency. So this is the diagram for that. And now let's see frequency division multiplexing, that is FDM. There is a separation of the whole spectrum into smaller non-overlapping frequency bands. Okay, so the God spaces are given to split these frequency bands. So God spaces are the spaces between the frequency bands. Okay, so the channel gets a certain band of the spectrum or for the whole time. The channel gets the certain band of spectrum for the whole time, so that the receiver has to tune to the sender frequency. The particular receivers can tune to the sender's frequency so that they can use the entire band for the particular time. Okay, so again the God spaces are needed to avoid the frequency band overlapping. Here also the God spaces are needed to avoid the frequency overlapping, also called as adjacent channel interference. This is also called as adjacent channel interference. So this scheme is used for radio stations within the same region where each radio station has its own frequency. So this is very simple multiplexing scheme. It does not need any complex coordination between the sender and the receiver. So the receiver only has to tune to the specific sender. That is the main thing. Okay, so the receiver have to tune its frequency according to the sender. It is enough. Okay, so this is the diagram. So here also we have 6 channels K1 to K6 and coordinates C, T and F, and this is bands are splitted accordingly. Okay, so this is the diagram for the frequency division multiplexing. So here are some advantages and disadvantages of FDM. So the advantages are no dynamic coordination is necessary, and it works also for analog signals. That is a main advantage. In the case of disadvantages, while the radio station broadcasts 24 hours a day, mobile communication typically takes place only for a few minutes at a time. So assigning a separate frequency for each possible communication scenario would be a tremendous waste of this frequency resources. Okay, so this waste of frequency resources is a main disadvantage, because the radio stations completely broadcast for 24 hours a day. Okay, so then additionally the fixed assignment of a frequency to a sender makes the scheme very inflexible and limits the number of senders, makes the scheme very inflexible. Okay, so it limits the number of senders also. So this is a drawback. Then let's move to the time division multiplexing. So this is called as TDM. Here also we have a channel Ki. It is given the whole bandwidth for the certain amount of time. So the entire bandwidth is given for the channel for the whole amount of or on certain amount of time, so that all the senders can use the same frequency but at different points of time. Okay, so the senders can use the same frequency but at the different point of time. So again God spaces now represents the time gaps here. There the God spaces represents the frequency gaps. Here the time God space represents the time gaps, and they have to separate the different periods when the senders use the medium. Okay, so if two transmissions overlap in time, they are called as co-channel interference. If two transmissions overlap in a time, they are called as co-channel interference. So we have given here a highway example, that is when two cars are moving, so the gaps between the cars is known as the guard space, and when they collide with each other, that when they result in an accident, that is similar to the interference. In order to understand, they have given this example. So to avoid this type of interference, precise synchronization between different senders is necessary. Okay, in order to avoid, we need precise synchronization between the senders is necessary. So there are some advantages and disadvantages. The advantages is only one carrier in the medium at any time, and another advantage is throughput high even for many users. The disadvantage is precise clock synchronization is necessary, and this is the diagram for the time division multiplexing. And the frequency and time division multiplexing can be combined. Okay, that is a channel gets a certain frequency band for a certain amount of time. That is the combination of this frequency and time division multiplexing. Now the God spaces are needed both in the time and in frequency dimension. Example GSM. So there are advantages and disadvantages also. The advantages in the case, advantages or a better protection against tapping, protection against frequency selective interference. Disadvantages or precise clock synchronization is necessary. Then when we move for code division multiplexing, here the figure shows the code division multiplexing, where all the channels Ki uses the same frequency at the same time for transmission, but separation is achieved through because the channel uses its own code. So God spaces are realized by using codes with the necessary distance in code space, example orthogonal codes, implemented using spread spectrum technology. Okay. So the advantages of code division multiplexing is bandwidth is efficient, no coordination and synchronization is necessary, good protection against interference and tapping, and the disadvantage is precise power control required more complex signal regeneration. These are the questions which could be asked related to this topic. Thank you.